Let's understand the basic of SHM progressive wave. Now suppose this is a wave, obviously it's a sine curve. Alright, now it starts from origin and we are going to compare two particles, one particle here and one particle over here. Particle over here, obviously it's a sine curve, so it has equation A sine omega t, whereas the particle over here is, that is particle P, it lags in phase by delta. By delta, we know this is lambda or 2 pi. So this is delta and x. Alright, in phase it is 2 pi. This is 2 pi in phase and this is delta in phase. And by length it is lambda and this is x. Alright, so a particle lags in phase by delta and this or distance x. Alright, so the equation for this particle would be y is equal to a sine omega t minus delta. As it is lagging, why am I calling it lagging? Because see, this has already started and this is going to start from here, lazy lump. Okay, so it's going to start with, that's the reason why this is lagging in phase. Alright, okay, simple harmonic progressive wave traveling in positive direction of x-axis, traveling in positive direction of x-axis, y is equal to displacement, x is equal to position of particle. Alright, so this is displacement and this is position of particle. So alright, so this is the position of particle and this is the displacement of particle. Fine. So y is equal to a sine omega t is the equation. Displacement at any instant t of particle O is y is equal to a sine omega t, whereas for p it is equal to y is equal to a sine omega t minus delta. Okay, when the particle p is at positive direction of x-axis. Keep this in mind clearly. Okay, now let us understand what happens if the particle p, whom we call lazy, is on this direction. If it is in this direction, if p is in this direction, then obviously it leads by delta in terms of phase and x in terms of distance, in terms of length. Alright, so now the equation for particle p would be y is equal to a sine omega t plus delta. Plus, why? Because it leads, whereas for this it would be y is equal to a sine omega t. Why? Because this now lags. I hope it is understood. So whenever particle p is on negative direction of x-axis, the equation is plus delta. Alright, in the equation we have plus delta, plus phase, because it's leading. Whenever the particle is on this side, it would be a sine omega t minus delta, because that particle is lagging. Fine. But when particle, so that's what I jotted down over here. But when particle p is at negative direction of x-axis, then the equation would be y is equal to a sine omega t plus delta. Okay. Now, as particle p leads by phase delta. Alright. Okay. But now for further derivation, what we are doing is we are going in for this situation. Alright. So we have assumed the equation to be y is equal to a sine omega t minus delta. Okay, now let's check out all the derivations. These all derivations are very much essential for us for numerical purpose. Okay, so a sine omega t minus 2 pi x over lambda. Why? Unitary method. See, lambda corresponds to 2 pi. Therefore, x corresponds to how much? Unitary method. So 2 pi multiplied by x, and I hope you understood this relationship. This is the normal relationship. Lambda is 2 pi. So x corresponds to how many radians? So length versus radians. So length versus radians. So in terms of radians, it would be 2 pi multiplied by x divided by lambda. So that's what we substitute over here. 2 pi x over lambda instead of phase delta. Okay, so that also becomes a sine 2 pi t over t. What did we do? We just opened this up, omega, which is 2 pi over capital T, time period, and this is time at an interval, time interval. This is time interval, this is periodic time, minus 2 pi x over lambda. Obviously, thought comes to our mind is taking out 2 pi. So we take 2 pi common. So this becomes the formula. Then we also know 1 over t is n. So we put nt x over lambda. When we take n out, what happens is this n goes, but we get another n at denominator. So the formula becomes 2 pi n t minus x over n lambda. Now we know v is equal to n lambda. So the equation, this equation comes into picture. And then further, let's understand this part. Now see, 2 pi n vt minus x over v. What did we do? Just took LCM, right? LCM. And then what did we do? We took v out. Alright, we can take v out. If we take v out here, vt minus x remains in the bracket. Alright, so we took v out, so vt minus x remained here. Now v also we know is equal to n lambda. We know that v is equal to n lambda. So n cancels. So what remains is 2 pi lambda into vt minus x. These are all very much essential for us for numerical purpose. Now what I have done over here is, that I've just tried to, so now this was when p is at positive direction of x-axis. This is when p would be leading, and at negative, when p would be in negative direction of x-axis, so it would be leading particle p. Same would be for p leading or at negative direction of axis. So when the particle is in negative direction of x-axis, the sign which is there would all change to positive. Alright, so keep this in mind. So these two equations are the basic equations which you have got to keep in mind. There are lots of numericals based on these equations. Alright, so please do well, study well, understand well, and put in your effort.